Hi, today's video is going to be about clamping ammeters and how to use them. So it's going to be a little similar to my multimeter tutorial which I uploaded previously. So if you have not watched that, I recommend that you can watch that, but so that you can understand this better. For now, let us proceed to the clamping ammeter video. Okay, so now you might ask me as to what is this clamping ammeter, what exactly does it do, and why exactly do we use this? So let me get started with that. See, a clamping ammeter is an instrumentation device which is similar to the multimeter itself. The only difference is that this can also measure current. Now you might ask like, okay, a multimeter will also measure current, so what is special about this? Well, the specialty about this is that this can measure both alternating current and direct current, and it will measure current in higher values. If you look at it, you can measure up to 600 amperes of current, either AC or DC with this. Now let me just be a little specific that these particular models of ammeters are known as AC DC ammeters, which means they can also measure DC currents, and these are on the expensive side of the system. But if you get little bit inexpensive ammeters, then they will not measure DC current, but you can still measure the other parameters. So for me, I specifically purchased a DC clamping meter because I need to measure DC currents for the projects. Note that there's no clamp meter that can measure only DC. You can get clamp meters that measure only AC, or things like this which measure both AC and DC also. Okay, so now I have set this to DC. Now note that I am doing like this has an auto ranging voltage measurement, because of which I don't need to set any limits. So which is why I am checking DC in its auto range itself. Now once it is set to DC voltage here, you can measure any DC source. If you want to measure AC, just press this function button, it will switch to AC. Now that I am measuring DC, I switch to DC. So let us measure two voltages. Here I have my failed lead acid battery from one of my old UPS, which is not holding any charge, but still let us measure the voltage. Okay, so if you can see, it is measuring approximately 8.34 volts, which is quite accurate, and yeah, this is a failed one. Another example, I'll bring in my lithium ferrous phosphate battery, which I purchased recently, 12 volt LiFePO4 battery, and let me measure the voltage for this one. Okay, .2 volts almost. So yes, you can measure DC voltages quite easily with this meter in its auto range. Okay, so let us find out how we can measure DC current. So what I'm going to do is I'm going to change this to 60 amperes range, and now it is naturally going to AC by default. So now that I need to measure DC, I press this and make it DC. It might record some stray readings due to the presence of DC voltages in and around the system, but you need to zero it and make sure it is 0 before you take the reading. Now for measuring the DC current, what I'm going to do is I have my charge controller hooked to this lithium ferrous phosphate battery, and I'm going to turn it on. Okay, so the charge controller has been turned on, and I'm going to just see how much current this charge controller consumes on no load. Now let me just put it around the one wire. It is approximately 20 milliamps, if you can see, 20 to 30 milliamps. Don't move this around too much because it will affect the reading in that case, but it's approximately 20 to 30 milliamps. Now one thing which you should note is that while you connect your ammeter, you either connect it into the negative or you connect it to the positive. Do not connect it to both the wires at the same time. That is, do not enclose both these wires within the ammeter at the same time. In that case, the negative and the positive will cancel each other, so your reading will come to 0 instead of the original one. So like I said, I was able to successfully measure 20 to 30 milliamps. And in order to, after you measure DC currents, there are tendencies that the reading will continue to stay. This is why you need to zero it. Fine. Now that we have measured DC voltage and DC current, let me show you how you can measure one more quantity known as NCV. NCV stands for non-contact voltage, which means this part of the clamping ammeter will detect voltage without having any physical contact to the system. Now this won't measure the value of voltage, rather it will just detect whether the voltage is there or not. It's an ideal way to find out where your conduits are when you are drilling into the walls. That is one good use. So let me just show an example. I have switched to NCV. I bring my battery nearby. So it generally doesn't measure the DC output that much unless there's some AC leakage into it. Okay, so if you take a look at my switchboard here, I have set it to NCV mode and I'm going to keep it nearby. If you notice it, that it's constantly detecting the level of NCV. The beeping and the blinking indicates that there is some non-contact voltage that has been detected. Even if I bring it to my spike strip on the top of the room, same story. Now another way you can actually find out how you can use this feature is, let's say you have a switchboard here and I would like to hang a photo frame somewhere near the switchboard. It would be dangerous if I drill my drill machine into the conduit and short the wires, which is why I can see where the conduit goes, approximately that is. Can start slowly and like take my meter around, so it will be able to detect where the wires are. See, if you notice, there's a conduit going upwards, because of which the meter is continuously blinking. Of course, this is not as accurate as a genuine tester, but it will still do the task in many cases. Okay. For now, let us see how to measure the frequency. For measuring frequency, you need to come here to see this frequency count. Do not go for frequency percentage, rather go for just frequency. Now when you connect it here, it naturally goes into DC voltage mode, which is why you need to change the function to frequency. What you need to do is, first you change from DC to AC, and from AC, when you press the Hertz button, it changes to frequency. Now to measure the frequency of any system, what you need to do is just bring this probe very close to any wire that is carrying the AC current. So now if you see this wire that is carrying the current to my tube light, I have plugged it in there and it's showing 50 Hertz. Now in India, the frequency always fluctuates between 50 to 60 Hertz. So this is quite an accurate reading, but on an average, it's around 50 Hertz. You can see the fluctuations. Same story, even if now what you should notice is that if you just randomly bring it to any plug socket, then it's less likely to detect the frequency. You need to be close proximity to some device that is actually consuming the power for it to measure the frequency. Okay, so the question arises as to whether do you really need a clamping ammeter? See, the truth is, if you work on very basic projects, then you will not necessarily need a clamp meter. However, if you work on projects that are related to core electrical systems, solar power and off-grid systems, test on EV batteries and all these things, make your own e-bike and similar projects which require a lot of measurements, then in that case, using a clamping ammeter is really useful. It's because a normal multimeter will only measure up to 10 amps of current and in some cases around 20 amperes. But this clamping ammeter will measure much higher current values, in this case up to 600 amperes, while there are some which can go up to 2000 amperes also. Besides, when you use these clamp meters, you don't need to break open that circuit. You can just hang it around one wire and it will show you the reading. Now one more question might be like, Why is it that some clamp meters only measure AC while very few, like the one that I have, measure both AC and DC? See, the truth is, clamp meters were technically designed only to measure AC current, because it's only through AC that you can get some good quality of electromagnetic induction that can be captured by another coil using the mutual induction concept. DC clamp meters are a much newer technology which have a Hall effect sensor placed inside them. You see that small square piece? Inside this small square piece, you can see that there's a Hall effect sensor placed inside it, due to which it can measure the flow of current through that Hall effect principle, due to which it's able to measure DC also. Now, due to the incorporation of Hall effect sensor and few expensive electronics, DC clamp meters are quite expensive. For example, the one that I have here is approximately 4,000 Indian rupees, which is the least expensive one out there. I'll put a link for this in the description. If you're interested, you can purchase it. So what are the other advantages of having this one? Obviously, you have non-contact voltage, you can measure frequency, and you can also measure temperature using a type K probe, which is also a useful feature here. And you can even measure capacitor values, resistor values, and you can measure diodes and check continuity as well. And of course, this is a true RMS meter, which means that you will not get any errors in the RMS reading as well. And you can even measure the frequency, which is a good thing, most of which without opening up the circuit. Now you might ask, okay, are there any disadvantages for this? Truth is, there are no specific disadvantages which I can think of. It does almost the exact same job as the multimeter, but the only disadvantage which this one poses is that for very small values of current, like the milliamperes range and all, this will be notoriously inaccurate. It cannot measure such low values of current with so much of accuracy. In that situation, for currents of less than 5 to 10 amps, it's better to use a multimeter itself. But if your current values are going to go beyond that, it's better to use this one itself. Except for its inaccuracy in measuring smaller current values, there are no specific disadvantages which this will pose, and it's surely a good investment. Of course, just note the type of meter which you are purchasing. If it's an AC only meter, then you cannot measure DC currents, and there are no DC only meters, either AC/DC like this one or only AC. Okay, so before that, I would like to say one more important thing as to what is the best advantage that these clamp ammeters provide. See, the best advantage that these clamp meters provide is one of the most common mistakes that even the most skilled electrical engineers make, is that in a normal multimeter there are 3 ports: common, voltage and current, for measuring current. Now in case the probe has been switched to the current mode and has not been switched back to voltage mode, and we directly go to measure voltage for a source like a battery or a plug socket, we get a violent explosion. But here, since there are only 2 probes, there are no ways of creating that type of a situation, as there is only 2 probes and current always gets measured through this one. So that is one great advantage that it has, that you are less likely to damage your meter or the circuit. Before concluding, let me just quickly go through the manual of this meter. DC current can be measured like 60 amperes to 600 amperes, but if you are measuring 600 amperes totally, you can do it for a maximum of 1 minute. If you measure a value of 600 amperes for more than 1 minute or go beyond this, then the meter will get destroyed permanently, and it's very expensive, so that will be a huge problem. Same is the case with AC current. Just make sure that you're below 600 amperes for this particular model, and for the other models below 1000 amperes or 2000 depending on what they say. Voltage has the same thing. Do not measure more than 600 volts of AC or DC. Measure like much lesser than that itself. And when it comes to this resistance, then you can only measure till 60 mega ohms, and frequency you can measure up to 1 megahertz. Do not measure more than that, otherwise you risk damage too. And capacitors up to 60 millifarads only. Do not exceed this either. Okay, So basic operation is just go through this instruction manual before you start using the device, and then you'll be able to use it without any errors. Okay, so I'm concluding this video for now. Thank you for watching. Like, comment, share and subscribe. Stay tuned. I will see you in the next video.